In the previous section, I gave you the scale factor. Previous example gave you the scale factor. Now, the directions are a little different. It says find the scale factor of the similar polygons and solve for x. So I tell you that they are similar. So 0.1 for finding the scale factor, 0.2 for solving for x. So scale factor is a matter of finding two corresponding sides. Now this one doesn't say right to left, small to large, so I can set up the scale factor however I want. So I can say 24 over 8, or sorry, 24 over 4. I can reduce that to 6 over 1. That is my scale factor. So that's my first part of the problem. My second part of the problem is to actually solve for x. So I can either use 24 over 4 or I can use my reduced 6 over 1. Since I went from the big to the little, I have to put the big side, 8 plus 4x on the top, the smaller one on the bottom. We're going to put our parentheses in before we cross multiply. We have 8 plus 4x equals 48. Subtract 8 from both sides, divide by 4, and x is 10. Now, slightly new notation in this figure. We're used to seeing congruency statements. This is the same idea. This is called a similarity statement. Remember, it tells corresponding sides. It tells us how this matches up. So I know that QR matches up with LQ. So that is how I can get my corresponding sides matched up with my corresponding sides, because Q to S is the same as Q to M. So if I'm going to find K, my first choice is to put these together, and I'm going to say smaller to larger. So K is 16 over 56. Common factor of 4 is going to be 4 over 14. There's still a common factor in there. 2 over 7 is my scale factor. So then when I go to find this missing piece right here, I will have small over large. So I'm going to put my 2 over 7 is equal to, so my smaller triangle, 10 over x. So keep in mind, if I use this one first in the smaller, I have to use this one first in my other proportion. And so when I cross multiply, I have 2x is equal to 70 and x is 35. Now you should also do a quick visual. This, I am getting bigger, so I had better have an answer bigger than 10, and it should be within a reasonable size if you think about blowing it up or shrinking it with the other sides. Now this figure also has a similarity statement, and I have to be really careful and thoughtful about my pieces. So I have triangle SBC is one of my triangles. It has these 3 coordinates, and I also have triangle SUT, which has these coordinates. Be careful that you don't grab little pieces down here, because a portion that is not a full side of a triangle would not correspond to a full side of a triangle. You have to have side to side. So you can pick any of the corresponding sides you want. So let's just initially say, let's compare these two. So K is, if we do small to large again, 44 over 99. Those have a common factor of 11, so my scale factor is 4/9. Now I can use that to find this missing side. So 4 over 9 is the same ratio as 24 corresponds to 7x minus 2. Again, I took a side and compared to an entire side. I could have used 36 and 81 to find my scale factor, or I could have set them up equal. Lock in my parentheses. 4 times 7x minus 2 equals 9 times 24. So I have 28x minus 8 is equal to 216. Add 8 to both sides. 2, 4. And when I divide both sides by 28, x is 8. So if we look at one more rule, one more example here, we're going to look at our last transformation, which is a dilation. And this is the one that will create similar figures. So we're going to take our x and our y, and we're going to make our new coordinates by multiplying each coordinate by our scale factor. So what I'm going to do is I'm going to just take my original figure and I'm going to blow it up by multiplying by k. If k is greater than 1, my figure gets bigger. If k is between 0 and 1, my figure gets smaller. We never have k's that are negative. Again, the prime notation stands, so to move from my pink figure A, B, and C to my blue figure, what happened to each of the coordinates? How did I go from -2 to 4, 4? Well, I multiplied by my k factor, and k happens to be 2 in this picture. I took all of the pink coordinates and I multiplied by 2 to make the blue figure, and I blew it up 2 times bigger. So if you see an example like this, if polygon RTGH has those vertices and undergoes a dilation, the transformation, with a scale factor of 3, so k is 3, what are the new coordinates? Well, we are going to take 3 times every coordinate in here. So r prime is going to be -12, 3. T prime is going to be 6, 9. If this is R, this is T, this is G, and this is H. G prime, 2 times 3, -1 times 3. I'm going to get 6, -3. And H prime is -12, -9. So all I did to each of the coordinates was apply the rule of 3x, 3y, because k was 3. If we look at an example with graphing, graph ABCD with those vertices, and then dilation with a scale factor of 1/3, so my figure is going to get smaller, and graph that new picture. So if I am graphing -6, get my graph going right here, -6, 6, there's A, -6, -6, there's B, 6, -6, there's C, and D is at 6, 6. I have a nice big square. And if I think about applying the rule of T prime is 1/3 of x, 1/3 of y, then every one of these, so A prime, I'm going to take 1/3 times -6, 1/3 times 6. Multiplying by 1/3 is the same as dividing by 3. And so A prime is going to become -2, 2. And then B prime, -6, -6 divided by 3 is going to become -2, -2. C prime will become 2, -2. And D prime will become 2, 2 if I take 6, 6 and divide. And I end up with this similar but smaller rectangle. And that is the end of section 3. Good luck with your homework.